What if I told you that the hunger humans felt 20,000 years ago is still controlling your brain today? What if the reason you cannot resist sugar, why your body stores fat, even when you do not want it to, why you panic at scarcity, has its origins in freezing nights of the Ice Age? Today we are going to enter the most brutal winter our species has endured, and what you discover at the end is going to forever change the way you understand your own relationship with food. Before we begin, I want you to imagine something. Imagine that you have gone 3 weeks without eating properly. I am not talking about a diet. I am talking about real hunger. Your fat reserves are depleting. Your body has begun to consume muscle. Your mind no longer thinks clearly. Every thought revolves around a single thing: food. Now imagine that outside it is minus 30 degrees. That snow has been falling nonstop for 2 months. That the animals have migrated or are buried under meters of ice, and that you are in charge of an entire family that depends on you to survive. That is not a disaster movie. That was the average winter for millions of human beings during the Ice Age. And the question I want you to keep in mind from this moment on is the following: how did they survive? Not in general terms, but with the level of detail that a real survival story deserves. What did they eat when there was nothing to eat? What happened to their bodies during weeks of extreme hunger? What happened to their minds? And, above all, what is the price they paid to survive, and why are we still paying it today? To truly understand what hunger was like in the Ice Age, first I need to place you in the world that existed then. Because the most common mistake we make when imagining that period is projecting onto it a slightly colder version of the world we know. The reality was radically different. The last glacial maximum, the most extreme point of the last glaciation, occurred approximately 26,000 to 19,000 years ago. During that period, enormous ice sheets covered most of North America and Northern Europe. The sea level was between 100 and 120 meters lower, which means that land masses existed that are submerged today. Global temperatures were between 6 and 10 degrees Celsius colder than current ones. 6 to 10 degrees might sound like a little, but in climatic terms, it is the difference between a temperate ecosystem and a periglacial steppe battered by Arctic winds. It is the difference between forests with abundant fauna and bare tundra landscapes where life can barely sustain itself. The humans who lived in Central and Eastern Europe during that period faced winters that lasted between 6 and 8 months. Not the mild winter we know in current European latitudes, winters with temperatures that regularly dropped to minus 40 degrees on the coldest nights, with snowfalls that could last weeks, with winds that made the wind chill completely incompatible with outdoor survival. And in that context, the search for food was the absolute axis of human existence. But before going into the details of how they fed themselves or starved to death, I need to propose something to you that will seem like a contradiction, but which is fundamental to understanding the whole story. The humans of the Upper Paleolithic were not primitive. They were not less intelligent than us. Their brains were identical in size and structure to yours. And in some aspects, they were better than us at what mattered most for surviving. They knew their environment with a depth that most modern human beings cannot imagine. Those humans knew where bears hibernated. They knew which roots could be eaten buried under the snow. They knew how to read the sky and predict storms a week in advance. They knew which animal bones contained enough caloric marrow to keep you alive a few more days, and yet they still starved to death, sometimes in terrible ways. How is it possible that being so intelligent and adapted to the environment starved to death with that frequency? The answer lies in a brutal and simple equation. The calories available during the winter months simply were not enough to keep everyone alive. Not due to ignorance, not due to lack of skill, but because the environment was at certain times radically hostile to human life. Now we are going to get into the biology of hunger, because to understand what those humans lived through, you need to understand what happens in the body and mind when food deprivation extends for weeks. The first significant day without eating is relatively manageable. Your body has glucose reserves stored in the liver and muscles in the form of glycogen, those reserves last approximately between 12 and 24 hours of normal activity. On the second and third day, the body enters a different metabolic state. When glucose reserves are depleted, the liver begins to produce ketone bodies from stored fats. Your brain, which normally works almost exclusively on glucose, begins to adapt and use these ketone bodies as alternative fuel. This process is called ketosis and has notable physical and mental effects. Physically, you reduce energy expenditure. Your body temperature drops slightly. Your movements become slower. Your immune system begins to function less efficiently. Mentally, ketosis can produce altered states of consciousness. Some researchers argue that the trance and vision states that we document in shamanic rituals of Paleolithic societies could be related to periods of prolonged fasting. Extreme hunger alters the perception of reality in very specific ways. After a week without adequate caloric intake, the body begins to consume muscle protein aggressively, and this is where hunger becomes dangerous in a way that goes beyond discomfort. When the body consumes muscle, it does not distinguish between leg muscle and heart muscle. Prolonged starvation can cause cardiac arrhythmias. It can cause kidney failure. It can cause the collapse of the immune system, which leaves the individual completely vulnerable to infections that under normal conditions would be minor. And while all this happens in the body, in the mind, something equally dramatic happens. The Minnesota starvation experiment, carried out in 1944 by Ansel Keys with 36 healthy volunteers, gives us the best scientific portrait of what happens in human psychology during severe hunger. Although this experiment did not reach the levels of starvation that humans of the Paleolithic would have experienced, its results are revealing. After weeks of severe caloric restriction, the volunteers began to experience a phenomenon that researchers called food obsession. The participants could not stop thinking about food. They collected recipes. It looked at cookbooks for hours, dreamed about food. Some of them described the experience as if food were the only real thing in the world. Along with food obsession appeared extreme irritability, depression, anxiety, difficulty concentrating, emotional apathy, and, in some cases, behaviors that the participants themselves described as incompatible with their usual personalities. Now multiply that by months, by an entire winter, in an environment of extreme cold, without heating, without the certainty that spring would bring enough food, and with the responsibility of keeping the children and the elderly of the group alive. That was the real hell of the Ice Age. Not the mammoths, not the cold, the hunger. But here is the question I promised to answer and have not answered yet. How did they survive? And the answer has 3 parts, each more fascinating than the last. The first part of the answer has to do with planning and storage. For decades, archaeologists assumed that the hunter-gatherers of the Paleolithic led a life of constant improvisation, hunting what they could, when they could, and without much long-term planning. This image has been completely revised by the most recent evidence. Archaeological sites in Eastern Europe and Siberia show clear evidence of food storage. Pits dug into the permafrost that functioned as natural freezers, where large amounts of meat and fat were preserved for months. Animal fat was particularly precious. It is calorie dense, preserves well in the cold, and can be obtained from multiple sources. Isotopic analyses of Paleolithic human bones show diets extremely rich in animal protein, with values suggesting that meat was the primary caloric source in many regions during the winter months. But they also show periods of acute caloric deficit, visible in the so-called Harris lines, interruptions in bone growth that occurred during periods of severe malnutrition, similar to the rings of a tree. Those Harris lines are like signatures of hunger engraved on the skeleton and are present in a significant proportion of human remains from the upper Paleolithic. But storage only solved part of the problem. The other part was solved by something completely different. The second part of the answer is biological adaptation. And this is the point where the history of the Ice Age connects directly to your body today. The humans who survived the most brutal winters of the Ice Age did not do so by chance. They survived because they possessed genetic characteristics that gave them advantages in conditions of extreme scarcity. And those characteristics were strongly selected by millennia of cycles of hunger and abundance. The geneticist James Neal proposed in 1962 the thrifty gene hypothesis to explain the surprisingly high prevalence of type 2 diabetes in modern populations. His argument was the following: the genes that predisposed to obesity and insulin resistance were enormously advantageous in an environment of cyclical food scarcity, like the Paleolithic. In simple terms, if your body is extremely efficient at storing fat during periods of abundance, you survive periods of scarcity better. If you are able to drastically reduce your basal metabolism when food is scarce, if you consume your reserves more slowly and have more time to find food before dying, the problem is that in those same genes that kept you alive in the Ice Age. In the modern environment of constant caloric abundance, become a trap. There are no longer winters of hunger that compensate for those of abundance. There is only permanent abundance. And the thrifty genes keep doing their job, accumulating fat for a winter that no longer arrives. This hypothesis explains why the rates of obesity and type 2 diabetes are so high in populations that have historically experienced the most intense selection pressures related to food scarcity. But the thrifty genes are only a part of the biological adaptation to famine. There is something else we inherited from the Ice Age, and that is equally revealing. Your brain has a hardwired preference. That is, genetically programmed for foods rich in fats and sugars. It is not a character flaw. It is an evolutionary adaptation. In the Paleolithic environment, foods rich in fat and sugar were extraordinarily rare and extremely valuable. Fat was the most calorie-dense macronutrient. Sugar in the form of ripe fruits or honey was a rapidly available energy source that nature offered, only in very specific seasons. Your brain learned, over hundreds of thousands of years of evolution, to release dopamine, the molecule of pleasure and reward, in response to those foods, because a brain that felt intense pleasure upon finding caloric foods was a brain that actively sought out those foods, prioritized them, remembered them, and returned to the places where it had found them. That reward system was absolutely essential for survival during the Ice Age. Today, in a supermarket full of products designed specifically to activate that reward system, it becomes something completely different. The food industry did not discover by accident that combining fat, sugar, and salt in the right proportions creates a practically irresistible food. It discovered it because those are exactly the combinations that activate the reward circuits that the Ice Age engraved in our brains. Every time you feel that you cannot stop eating something ultra-processed, it is not a lack of willpower. It is the Ice Age speaking through your neurology. But before getting to the third element of the answer about how they survived, I need to tell you something about the social dimension of hunger, which is rarely mentioned and which is perhaps the most important in human groups of the Paleolithic. Hunger was never an individual issue. It was a collective issue. And the responses to extreme hunger were also collective. Analyses of food distribution patterns at archaeological sites show something extraordinary. In most of the Paleolithic groups studied, food was shared in a relatively egalitarian way. This was not a philosophical ideal. It was a survival strategy. Imagine a group of 40 people in any given week. Perhaps 10 hunters go out and only 2 return with significant prey. If those 2 keep all the meat for themselves and their immediate families, in the short term, they are fine. But in the long term, they have weakened the group. They have reduced the collective hunting strength. They have decreased the number of warriors available to defend the camp. They have created social tensions that can destroy the cohesion of the group. Sharing food was not generosity. It was group intelligence. But there were situations in which even that sharing was not enough. And this is where the story gets darker and more revealing. Bone analyses in Paleolithic sites in Europe, America, and Asia show unequivocal evidence of a behavior that archaeologists document carefully and that the general public rarely knows about: survival cannibalism. I am not talking about rituals. I am not talking about regular cultural practices. I am talking about evidence that in times of extreme starvation, some human groups consumed the corpses of the members who died. The bones with cut marks in the same patterns as the bones of hunted animals. The long bones fractured to extract the marrow in the same way that animal prey was treated. This evidence appears in enough Paleolithic sites that it cannot be dismissed as anomalies, and Beepley's evidence appears in anomalies. This does not speak of monstrosity. It speaks of the absolute brutality of the sinister conditions in which they lived and the desperation to which extreme hunger can lead. And it also speaks of the human capacity to do the unthinkable when the alternative is to let their own die. But there is something in this part of the story that seems even more significant to me than the act itself, and it is the psychological response that modern humans have when food scarcity reaches critical levels. Studies of human behavior in situations of extreme scarcity, from the ghettos of the Second World War to the famines of the 20th century, show a consistent pattern. When hunger crosses a certain threshold, moral values, social norms, and family ties can collapse in ways that well-fed individuals would consider impossible in themselves. This does not mean that humans are inherently selfish or cruel. It means that extreme hunger alters cognition so profoundly that the brain enters a primitive survival mode that overrides circuits of empathy and long-term planning. This survival mode was, during the Ice Age, what kept the most resilient individuals alive, and its neurological consequences are also engraved in us. Now we reach the third part of the answer about how the humans of the Ice Age survived, and it is the one that has the most surprising consequences for understanding who we are today. The third part is technological and cultural innovation. As a direct response to hunger, this is the part that fascinates the most from a historical point of view, because it suggests that some of the most significant innovations in early human history were not driven by intellectual curiosity, but by hunger. Let us start with fire. Humans had been using fire opportunistically long before the Ice Age, taking advantage of natural wildfires. But the deliberate and constant control of fire, the ability to generate it when needed, became absolutely critical during the glaciations for reasons that go beyond warmth. Cooking food increases its digestibility, and therefore the usable calories of each meal. A cooked tuber provides between 30 and 40% more calories than the same raw tuber. Cooked meat releases proteins that would otherwise largely pass through the digestive system without being absorbed. In an environment of caloric scarcity, this difference can literally be the difference between life and death. The anthropologist Richard Wrangham argues in his work on cooking that fire, and cooking not only improved human nutrition, but allowed for the growth of the brain that defines us as a species. A large brain consumes a disproportionate amount of energy, and it was only possible to maintain it when cooking allowed enough calories to be extracted from available foods. In other words, the Ice Age, by pressing upon humans the need to maximize available calories, may have accelerated the development of culinary technology that finally allowed the cerebral development that made us who we are. Hunger made us smarter. Hunger made us human. But the innovation driven by hunger did not stop at fire. The most sophisticated tools of the Upper Paleolithic, bone-tipped harpoons, needles for sewing clothes that allowed greater mobility in the cold, traps and nets to hunt more efficiently, all this emerged in the context of an evolutionary and cultural pressure directly related to the need to get more food from an increasingly hostile environment. There is archaeological evidence suggesting that the maximum pressure of the last glacial maximum between 26,000 and 19,000 years ago coincides with a period of accelerated technological innovation in the brooded human groups that survived. as if the existential crisis of hunger and cold had acted as an engine of forced creativity. When resources are abundant, innovation is optional. When resources are depleted, innovate or die ceases to be a metaphor. There is something else I need to tell you. Something that most narratives about the Ice Age omit completely. Perhaps because it is uncomfortable. Perhaps because it does not fit with the heroic image we prefer of our ancestors. Not all human groups of the Ice Age survived. Genetic analysis of modern human populations shows demographic bottlenecks, that is, drastic reductions in population size at multiple moments in human history. Some of these bottlenecks coincide with the coldest and driest periods of the Ice Age. In some cases, the whole regional populations of humans went completely extinct. Their genetic lineages disappeared. The groups that lived in certain regions found no solution to the problem of hunger and died. Those who survived did not do so simply because they were smarter or braver. They did so because they possessed a combination of biological characteristics, ecological knowledge, social organization, and, in many cases, luck. The Ice Age was not an exam that everyone passed. It was a sieve that eliminated those who could not adapt. And now we reach the final twist I promised at the beginning, when you ask yourself what hunger was really like in the Ice Age. The most honest answer is brutal, constant, and transformative. But the most important answer does not speak of the past. It speaks of the present. Every mechanism that the human body developed to survive the winters of the Ice Age is still active in you. Right now, your tendency to feel hungrier after a period of caloric restriction is a survival mechanism that evolved so that you would overeat after famines, accumulating reserves for the next winter. Your preference for calorie-dense foods rich in fat and sugar is the Paleolithic reward system in action. Incapable of distinguishing between a wild tundra blueberry and a bag of industrial potato chips, your metabolism, which slows down when you eat fewer calories, frustrating your attempts to lose weight, is exactly the same mechanism that kept your ancestors alive during the longest winters. Your anxiety response to the prospect of not having enough food, that irrational panic you feel when the refrigerator is almost empty, even if you are not at real risk of going hungry, is the alarm system that the Ice Age installed in your nervous system, and that still does not know that the world has changed. You are not at war with your willpower when you struggle with your relationship with food. You are at war with 20,000 years of evolutionary pressure designed to keep you alive in conditions that no longer exist. This understanding does not solve the problem, but it completely reframes it. The millions of people who today struggle with obesity, with eating disorders, with a complex and often painful relationship with food, are not failing as individuals. They are experiencing the consequences of an evolutionary adaptation that worked perfectly for hundreds of thousands of years, and that the modern world turned into a trap. The humans of the Ice Age would have given anything to live in a world of constant food abundance. And it is precisely that world that their survival mechanisms make so difficult to navigate. The irony is perfect and cruel. The same mechanisms that saved us from hunger are the ones that today make us sick from excess. But there is something in this story that I find profoundly hopeful, and I want you to take that with you before closing. The humans of the Ice Age survived because they had something that no other species possessed to the same degree: the ability to adapt not only biologically, but culturally, to change their behaviors, their technologies, their social structures in response to conditions that changed faster than evolution could follow. This capacity for cultural adaptation is not engraved in our genes in the same way as the thrifty genes. It is available to any individual or society that decides to use it consciously. Understanding the Ice Age mechanisms that control our relationship with food does not automatically free us from them, but it gives us something our ancestors did not have: the possibility of seeing them, naming them, and consciously deciding how to respond. The Ice Age lasted for tens of thousands of years. Its traces in our biology are deep But the ability to recognize those traces and work with them instead, to of ignoring them, is precisely what makes us different from any other animal that survived that period. Those humans who starved on the coldest nights in the history of our species gave us two legacies. One is the biology of hunger that still inhabits us. The other is the intelligence to understand it. Which of the two we use is up to us. If this video changed the way you understand your own body, if it made you see history not as something distant, but as something that literally lives in your biology, then you know what to do. Share this. Like it. Subscribe if you want to keep finding stories here that connect the most remote past with the most immediate present. Next week, we are going to explore another chapter of human history that probably no one has told you in this way. A story that also touches something you feel every day without knowing where it comes from. Until then,